Something beyond Neptune is pulling entire worlds out of place. Not by accident, not by coincidence, with a mass 5 times heavier than Earth. Far beyond Pluto, where sunlight is nearly 1,000 times weaker than it is here, a handful of frozen objects move in ways they shouldn't. Their orbits are stretched, tilted, and strangely aligned, as if they were all responding to the same invisible command. This is not speculation pulled from imagination. It comes from repeated simulations, from orbital calculations run over and over again. Remove the hidden mass, the pattern falls apart. Put it back, the pattern locks into place. We haven't seen this object. No telescope has captured it. And yet, something out there may be heavy enough to quietly rearrange the outer solar system. Astronomers call it Planet 9. But the real question isn't what it's called. The real question is this: are we missing an entire world orbiting our own sun? For decades, the solar system felt complete. 8 planets, Neptune at the edge. Beyond that, leftovers from formation. Cold debris drifting in silence. A finished structure. Stable. Mapped. Understood. But the outer solar system is difficult to observe. Objects there are small, faint, and move slowly. When astronomers began tracking more of them with better surveys, something unusual appeared. A cluster. Not physically close, but aligned. Imagine scattering pebbles across a frozen lake and discovering they all slid into the same narrow groove. Random motion does not normally create order. Gravity does. Several distant icy bodies follow elongated orbits that point in roughly the same direction in space. This is not something we expect if they formed independently. Computer simulations were run again and again. Remove any extra planet, the pattern dissolves. Add a distant massive world, the pattern stabilizes. Moreover, these objects aren't just pointing in the same direction. They're tilted on a nearly identical plane, about 30 degrees off from the rest of the planets. To have this alignment occur by chance is like tossing a handful of coins and having them all land perfectly on their edges. The mathematical odds against this occurring naturally are overwhelming. In repeated models, a consistent solution appears. A planet about 5 to 10 times the mass of Earth, orbiting extremely far away, hundreds of times farther from the Sun than we are. Its orbit would be stretched into a vast ellipse, taking perhaps 20,000 Earth years to complete one full loop. At that distance, sunlight is weak, about 900 times fainter than it is here. The Sun would look like an unusually bright star. And yet, even there, gravity still reaches, and gravity is enough. This is not proof, but it is a clean explanation. And in science, clean explanations demand attention. If Planet 9 is real, it is not a small object. It would be a world. Cold, distant, massive. And there are several possibilities for what kind of world it might be. Each one changes how we understand our solar system. Possibility 1. The frozen giant. The most accepted model suggests Planet 9 could be a smaller version of Neptune. Not a gas balloon like Jupiter, but a dense world wrapped in thick outer gases with deep layers of ice beneath. Water ice, methane ice, ammonia ice. At its distance, temperatures would remain locked in a permanent freeze. Clouds, if they exist, would move slowly under dim light. It may even glow faintly from leftover internal heat, the last energy from its formation 4.5 billion years ago. Some models suggest this planet did not form out there. It may have formed closer to the Sun, near Jupiter and Saturn, and during the early chaos of planetary migration, it may have been thrown outward. Not destroyed, just exiled. If that happened, Planet 9 would be a survivor of our solar system's violent youth, and its gravity today would quietly shape the frozen debris field far beyond Neptune. Possibility 2. The missing super-Earth. Another theory suggests something different. Not gaseous, not Neptune-like, but rocky. A super-Earth, 5 to 10 times heavier than our planet, with a solid surface buried beneath layers of frozen gases. Super-Earths are common around other stars. Thousands have been discovered. Yet our solar system doesn't seem to have one, unless we missed it. If Planet 9 is a super-Earth, it fills a strange gap in our planetary family. Its surface might be covered in frozen carbon dioxide and methane, mountains of rock beneath kilometers of ice. The sky would be dim. The sun would rise no brighter than a bright star at dusk. If you stood there, assuming you could survive the cold and pressure, the universe would dominate the sky. Stars would shine clearly, undisturbed by bright sunlight. This possibility is exciting because it suggests our solar system may not be as unusual as once thought. We may simply have overlooked one of its largest members. Possibility 3, something far stranger. Then there is the most extreme idea. What if Planet 9 is not a planet at all? What if it's a tiny black hole? Not one formed from a dying star, but one born in the earliest moments of the universe, when matter was compressed into dense pockets seconds after the Big Bang. Such an object could be no larger than a baseball, and yet weigh several times more than Earth. It would emit no light, reflect nothing. It would reveal itself only through gravity. From a distance, its effect on icy objects would look identical to that of a planet. The difference would be invisible. Some researchers have suggested small flashes of light might appear if it consumes tiny bits of debris, brief signals in the dark. But so far, no such signals have been confirmed. This idea is speculative, but it fits the mathematics. And sometimes mathematics leads before observation catches up. Or there may be no Planet 9 at all. The outer solar system is difficult to study. We only detect the brightest and largest objects. When data is incomplete, patterns can appear stronger than they truly are. Statistical bias can create ghosts. Another explanation suggests that millions of years ago, a passing star drifted relatively close to our solar system. Its gravity could have stretched the orbits of distant icy objects during a brief encounter. The star moved on, but the distortion remained. In that case, what we see today is not ongoing influence. It's an ancient scar. No hidden world required. This possibility is uncomfortable because it means the mysterious alignment might not signal something new. It might simply reflect limited data and cosmic history. If Planet 9 exists, it is extremely faint. At 400 to 800 times the Earth's sun distance, reflected sunlight barely reaches us. It would move across a sky slower than a glacier shifts across land, almost imperceptibly. The challenge is the sheer scale of the search. Imagine trying to find a single dark marble hidden in a massive inlit stadium using only a narrow penlight. That is the task facing the Vera C Rubin Observatory. It will scan the entire sky every few nights, searching for a shifter, a tiny speck moving against the backdrop of billions of fixed stars. If Planet 9 is there, its motion, however slow, should eventually reveal it. And if nothing appears, that result will matter just as much. At first glance, this sounds like a simple missing planet story, but it's not simple. If Planet 9 is a frozen giant, it proves planets can be thrown outward and remain bound to the sun. If it's a super-Earth, it suggests our planetary system mirrors the broader galaxy more closely than we thought. If it's a primordial black hole, it means an object born at the dawn of the time is orbiting within our own cosmic neighborhood. And if it doesn't exist, then we're confronting something equally powerful: the limits of observation, the way incomplete data shapes belief, the reminder that even in our own solar system, certainty is fragile. We often imagine exploration as something that happens far away, in distant galaxies, around alien stars. But sometimes discovery waits much closer, beyond Neptune, beyond Pluto, beyond the faint belt of icy remnants. Something may still be moving in silence. Either a massive world is tracing a 20,000-year orbit in darkness, or the outer solar system is teaching us a lesson about incomplete evidence. Both possibilities are powerful, because both mean the story of our solar system is not finished. Somewhere at the edge of sunlight, either a planet waits to be seen, or our understanding waits to be corrected. And until that faint moving speck appears, or fails to appear, the frontier remains open.